All right, here we got Steve doing our video for residential system design.
HVAC load calculation determines how much cooling or heating a building needs based on heat gain or heat loss. It's important because it'll ensure the system is properly sized for comfort and efficiency. It is performed by using manual J-load calculation either by hand or by computer software.
Okay. Renee, you got how a split system works. You want to walk us through that?
Split system works. There is actually copper piping that are hooked up together for the liquid line and the vapor lines. They do have to be powered up by 240 volts. Power up. They are braced, the copper pipes, to be able to cool, as you can tell. Nice. And the component that I appreciate the most, that does all the work harder, would be the indoor handle unit, the blower, which does amazing work. The condenser unit over here is the one that helps with the motor to do this job. That way, this bike can get the performance that they're looking for.
Okay. All right, here we go. Next, we got Eli. Common design values and system requirements or measurements.
So I got common design value and system measurement, and how we measure it is by testing the pressures. But first we got to get the head pressure and the suction pressure. And the low side, it's a little low, but it should be around 100 to 120, and the pressure on the high side should be 200 to 240. And we convert it by using the PT chart, and we get our saturation temp. And we can use our saturation temp and find the liquid temp and the suction temp on the copper lines, which we have down here. This is the liquid line temp, and this is the suction line temp. And we have the liquid line temp right here, the suction line temp right here, and we just subtract the saturation temp on the low side, which should be this one, and we subtract it from this suction line temp, and that's how we find our superheat. And our liquid line temp, we just subtract it from the liquid line, which is 70 on the suction line. On the liquid line temp. And this is how we get our subcool.
Okay. All right. Now we got Santos next on air filters.
For air filters, they're very crucial for the HVAC system because the HVAC system can't run without airflow. One of the first things you want to do when you're troubleshooting is you want to check airflow before you check pressures, because the airflow is going to affect pressures, it's going to affect the motor running, it's going to affect the inside motor running, it's going to affect the coil. And when you're getting your air filters and figuring out how you want to do it, you got to look at the manual for the condenser, air handler. You want to look at the manual for the air handler, and it'll tell you length by width by height of what type of filter you need. And there's also the MERV rating, which on most residential systems you want 8 to 11 because they're still good for filtration, but they're not too much, because there's some, the MERV is 1 to 20, and the higher ones are more for bacteria and stuff like that, and you don't want to restrict too much airflow to the unit. And you also want to make sure that it's key that you get the right size for the air handler, because you don't want air going through, slipping up in between the filter, and that's going to get the coil dirty, and it's just going to cause a lot more problems on the way.
All right, sounds good, Santos. Next, we got Jeremiah talking about thermostat operation.
All right, come with me. So this is our thermostat right here. And basically what the thermostat is, it's a device that basically controls whether you want your house to be on cool, or if it's cold outside, you want it on heat. So yeah, that's your thermostat. And basically what it does is so your set point right here, whatever you have your set point at, and if say you want your house cold and you put it on cool, you put it at 60, and you see how it says 68 right here. Well, your system's going to turn on so it can reach your desired temp. And for heating mode, say you want it up to 70 or hotter, however you want it at your house. And yeah, it's really cold outside, so your house is really cold. Well, your system and your furnace or heat pump, whatever you have, will turn on or reach your desired set point.
Okay. All right, thanks, Jeremiah. Next, we're going to do the liquid line filter dryer. The purpose of the liquid line filter dryer is to remove moisture and non-condensables from the system. Anytime any major component or any of the lines are open, the new filter dryer needs to be added. Also, as far as insulation on copper lines, for a regular air conditioning system, just the suction line is insulated, and that's to make sure that the temperature maintains consistent from the compressor all the way into where the metering device is at the air handler. If it's a heat pump system, then you would have both lines insulated to maintain the temperature consistency, whether it's on heat mode or cooling mode on a heat pump. Also, next we're talking about condensate drain line system and what it's for. It's mainly really to allow the moisture that's created and the humidity that builds up in the system to drain, and the pipe is designed normally like a P-trap style to allow water to moisture to seep out, but it also prevents bad fumes from going back into the air handler system. So we should always make sure there's water in the P-trap section. Also, another the primary and secondary. So that's the primary. The secondary line would be used, for example, for or an overflow switch. That's what the secondary normally is used for, or it might be just plugged up. Also, let's see what happens if the drain becomes clogged. Well, if it becomes clogged, it'll cause the drain pan to overflow, which will set off the normally closed float switch to open and shut off the power at the thermostat, and essentially shutting everything down. And that's pretty much it. And lastly, airflow restrictions. Airflow restrictions, like a dirty air filter, will cause the system to, if it's really clogged up, it'll cause the temperatures to go too low, and it will throw off all the parameters, the basic parameters of temperatures, like the boiling point at the evaporator, or the condensation point at the condenser unit will be thrown off, which could cause icing to happen. It'll if it's just a partial blockage to airflow, then it will create more consumption of power. So it'll be using more power to run the system, and it also lessen the lifespan of your components if the system isn't cleaned, on a consistent basis. Let me see. And also, I think that's pretty much it as far as airflow restrictions. And that's our video. Thanks. Bye.